Are you a data scientist? Do your tools make it easy to track your experiments, deploy to a machine learning model to production, and manage a GPU cluster? This free book from O'Reilly can teach you how to do all that. It's about tuning neural nets, making them scale, and then deploying them to the real world.
Our world is changing in many ways, and one of the things which is going to have a huge impact on our future is artificial intelligence, AI, bringing another industrial revolution. Previous industrial revolutions expended humans' mechanical power. This new revolution, this second machine age, is going to expand our cognitive abilities, our mental power. Computers are not just going to replace manual labor, but also mental labor. So, where do we stand today? You may have heard about what happened last March when a machine learning system called AlphaGo used deep learning to beat the world champion at the game of Go. Go is an ancient Chinese game which had been much more difficult for computers to master than the game of chess. How did we succeed now after decades of AI research? AlphaGo was trained to play Go. First, by watching over and over tens of millions of moves made by very strong human players. Then, by playing against itself, millions of games. Machine learning allows computers to learn from examples, to learn from data. Machine learning has turned out to be a key to cram knowledge into computers. And this is important, because knowledge is what enables intelligence. Putting knowledge into computers had been a challenge for previous approaches to AI. Why? There are many things which we know intuitively, so we cannot communicate them verbally. We do not have conscious access to that intuitive knowledge. How can we program computers with that knowledge? What's the solution? The solution is for machines to learn that knowledge by themselves, just as we do. And this is important, because knowledge is what enables intelligence. My mission has been to contribute to discover and understand principles of intelligence through learning, whether animal or human or machine learning. I and others believe that there are a few key principles, just like the laws of physics, simple principles which could explain our own intelligence and help us build intelligent machines. For example, think about the laws of aerodynamics, which are general enough to explain the flight of both birds and planes. Wouldn't it be amazing to discover such simple but powerful principles that would explain intelligence itself? Well, we've made some progress. My collaborators and I have contributed in recent years in a revolution in AI with our research on neural networks and deep learning, an approach to machine learning which is inspired by the brain. It started with speech recognition on your phones with neural networks since 2012. Shortly after came a breakthrough in computer vision. Computers can now do a pretty good job of recognizing the content of images. In fact, approaching human performance on some benchmarks over the last 5 years. A computer can now get an intuitive understanding of the visual appearance of a Go board that is comparable to that of the best human players. More recently, following some discoveries made in my lab, deep learning has been used to translate from one language to another, and you're going to start seeing this in Google Translate. This is expanding the computer's ability to understand and generate natural language. But don't be fooled. We are still very, very far from a machine that would be as able as humans to learn to master many aspects of our world. So let's take an example. Even a 2-year-old child is able to learn things in a way that computers are not able to do right now. A 2-year-old child actually masters intuitive physics. She knows when she drops a ball that it is going to fall down. When she spills some liquids, she expects the resulting mess. Her parents do not need to teach her about Newton's laws or differential equations. She discovers all these things by herself in an unsupervised way. Unsupervised learning actually remains one of the key challenges for AI. And it may take several more decades of fundamental research to crack that nut. Unsupervised learning is actually trying to discover representations of the data. Let me show you an example. Consider a page on the screen that you're seeing with your eyes, or that the computer is seeing as an image, a bunch of pixels. In order to answer a question about the content of the image, you need to understand its high-level meaning. And this high-level meaning corresponds to the highest level of representation in your brain. Lower down, you have the individual meaning of words, and even lower down, you have characters which make up the words. And those characters could be rendered in different ways with different strokes that make up the characters. And those strokes are made up of edges. And those edges are made up of pixels. So these are different levels of representation. But the pixels are not sufficient by themselves to make sense of the image, to answer a high-level question about the content of the page. Your brain actually has these different levels of representation, starting with neurons in the first visual area of cortex, V1, which recognize edges, and then neurons in the second visual area of cortex, V2, which recognize strokes and small shapes. Higher up, you have neurons which detect parts of objects and then objects and full scenes. Neural networks, when they're trained with images, can actually discover these types of levels of representation that match pretty well what we observe in the brain. Both biological neural networks, which are what you have in your brain, and the deep neural networks that we train on our machines can learn to transform from one level of representation to the next, with the higher levels corresponding to more abstract notions. For example, the abstract notion of the character A can be rendered in many different ways at the lowest levels, as many different configurations of pixels depending on the position, rotation, font, and so on. So, how do we learn these high levels of representations? One thing that has been very successful up to now in the applications of deep learning is what we call supervised learning. With supervised learning, the computer needs to be taken by the hand, and humans have to tell the computer the answer to many questions. For example, on millions and millions of images, humans have to tell the machine, well, for this image, it is a cat. For this image, it is a dog. For this image, it is a laptop. For this image, it is a keyboard, and so on, millions of times. This is very painful, and we use crowdsourcing to manage to do that. Although this is very powerful and we're already able to solve very interesting problems, humans are much stronger and they can learn over many more different aspects of the world in a much more autonomous way, just as we've seen with the 2-year-old child learning about intuitive physics. Unsupervised learning could also help us deal with self-driving cars. Let me explain what I mean. Unsupervised learning allows computers to project themselves into the future, to generate plausible futures conditioned on the current situation. And that allows computers to reason and to plan ahead, even for circumstances that they have not been trained on.